Welcome back to the Telco AI Forum. This next session is a fireside chat. We're going to discuss AI RAN, driving value and unlocking new revenue. To have that discussion, it's a pleasure to introduce Dr. Alex Choi, who's the chair of the AI RAN Alliance and principal fellow at SoftBank's Research Institute of Advanced Technology. So Alex, welcome and thank you for joining us.
Thank you for having me.
Let's get right into it here. The AI RAN Alliance debuted at Mobile World Congress in 2024, and since then, the organization steadily onboarded new members who are committed to this trifold mission of AI for RAN to enhance RAN performance, AI and RAN to build a shared infrastructure, converging compute and communications, then AI on RAN, which is meant to open up new applications and monetization opportunities. So maybe just tell us a little bit about how you're gauging the progress to date against that mission.
Sure. AI RAN Alliance, we've made tremendous progress since our debut. So today, AI RAN Alliance has grown to 94 members across 18 countries, spanning operators, technology companies, academia, and government. And Mobile World Congress this year at Barcelona, we showcased 10 cutting-edge AI RAN tech demos as a real proof of concepts. And these include breakthroughs in areas like AI native air interface design, deep learning for uplink channel estimation, mobility-aware power saving, advanced spectrum sensing, and dynamic AI model partitionings. So on the infrastructure side, we showcased how AI RAN orchestration can enable seamless multi-tenancy between AI and RAN workloads. So all these demos are not just hypothetical, and they validate the Alliance's trifold missions of AI for RAN and RAN on RAN is moving from concept to early real-world experimentations.
Yeah, very good. I had the opportunity to check out some of those demos at the Congress, and it really is compelling. To your point, this is not just theoretical things in the lab. This is really meaningful stuff that can impact how operators design, deploy, manage their networks. I did want to get some perspective from you, Alex. I'm not quite prepared to call it a schism just yet, but in my conversations with operators around the globe, and I'll use two examples here, but this is really around the role of GPU accelerated compute distributed throughout the RAN. We have T-Mobile US, for instance, founding member of AI RAN Alliance. They've made a number of announcements with NVIDIA and seem quite keen on GPU accelerated compute within the radio access network. If I look at a company like Verizon, we've had a lot of conversations with them and heard other public statements where they don't currently see advantageous economics around GPU in the RAN. They've gone so far to say everything that they'd like to do with AI in the RAN can be supported by CPUs. So just kind of help us understand why different operators may pursue different strategies and generally what does or does not make the case for GPU accelerated computing embedded in a radio access network?
That's a very, very good question. And the discussions around the future of a RAN computing platform has become especially fascinating because it's now deeply intertwined with the recent semiconductor advances and AI innovations. Traditionally, RAN processing has been anchored in DSP, digital signal processors, or ASIC-based architecture, but we are seeing clear indications that it's evolving toward a hybrid computing platform, meaning the combining CPU and GPUs. And this is because CPU and GPUs have a distinct strengths. For example, CPU cores are well suited for handling control plane task, radio access network control plane task, known as a layer 2 and 3. But when you get down to the layer 1 task, which is a physical layer, like a 5G NR signal processing, or the massive MIMO beamforming, where the massive parallel computation is required. So GPUs now start to make a lot of sense. It delivers clear cost performance advantages. So realistically, we will very likely see hybrid CPU and GPU platforms emerging as a dominant architecture for RAN, AI RAN in the coming years. And that said, it's not a one-size-fits-all solutions. For example, in rural or suburban areas where traffic loads are lower, then CPU-only RAN computing platform, for example, x86 or ARM-based CPU, can still be very cost-effective. But in urban and dense urban environments where traffic demand is much, much higher, it's increasingly likely that accelerators like GPUs will be needed. And when you layer in the growing spread of AI use cases across the network, particularly edge AI services, the case for GPU adoption becomes even stronger in the long term. And even if we are not talking about top tier, really high-end GPUs, it's worth considering mid-tier GPUs for future proofing, and especially as a small language model SLM inferencing demands begin to emerge at the edge. So for example, NVIDIA's recently announced their Arc Compact at Computex last week. This is a great example of type of solution that might fit these evolving needs. Of course, we shouldn't overlook that some vendors are still using ASIC-based inline layer 1 accelerators, which will continue to play a role, at least for the time being. So just to summarize, operators will need to map out our RAN computing, radio access network computing platform evolution carefully and taking into account several key factors. For example, the required cell capacity, the RAN topology, either distributed or centralized, and the level of AI integration and edge service demand, and increasingly energy efficiency, which has now emerged as a top priority. So having a very clear forward-looking roadmap is essential because RAN computing choices are no longer just about hardware. They are about enabling the next generation services and capabilities.
Yeah, that's exactly right. We tend to try to paint with a broad brush, but you're correct. There's no one size fits all. And as the use cases and services continue to evolve, there's going to be room for this hybrid approach to AI throughout the RAN. But specific to GPUs, I did want to get some perspective from you on GPU as a service. Just to help quantify this, Fortune Business recently published some research looking at the GPU as a service market and projected a almost 36% CAGR from 2024 to 2032. So that's really substantial growth that operators could stand to benefit from. And I know in your role with SoftBank, you and your colleagues are conducting a case study in central Tokyo around GPU as a service to evaluate a number of different variables, but particularly the return on investment outlook. So maybe you could share with our audience some details around that case study, any learnings that are emerging, and then, maybe give us a little bit of feedback on this idea that GPU as a service, the technology aside, might cause organizational issues in terms of a network engineering team not really wanting to share RAN resources with external users.
That's also very good questions. So for the first part, I believe you are referring to the blog posted on our company, the SoftBank website, but I don't have any additional updates on that. So so far, much of the contents has not been fully validated in the field. So I can only say it's still ongoing progress at this stage. For the second part, network engineering teams understandably worry about sharing a critical RAN resources with external workloads. And their KPIs are based on uptime, quality of service, and meeting SLAs. So any proposal to mix workloads can trigger strong pushback. But here's the key point. We are not talking about jeopardizing network performance and reliabilities. So we are using smart orchestration in AI RAN that guarantees workload isolations, which means RAN traffic always has a top priority, no matter what. The GPU resources allocated to AI applications are flexibly pulled back or throttled during peak telecom demand. Additionally, off-peak hours and underutilized capacity, which typically sit idle, are perfect windows to run GPU as a task. What operators have found so far is that RAN traffic shows highly predictable patterns, whether we look at daily, weekly, monthly cycles. So this predictability combined with the advanced AI-driven forecasting models allows us to make extremely accurate resource allocation predictions. And lastly, let me make a few additional comments on why AI RAN is driving, we are driving AI and RAN and AI on RAN R&D, research and development. What we aim to achieve through AI and RAN and on RAN is the realization of a new operating system for networked AI data centers, or you can call it new neo data centers that can enable transformation of telecom edge infrastructure to support massively distributed edge AI data center with connectivities. So while if you look at the landscape, today's AI data centers are largely started in a centralized form, which is the rural areas where you can get the cheaper energies. So we anticipate that edge AI data centers will emerge in the near futures because it's closer to the end users. To leverage this collectively as a vast virtual AI data centers, we will need a new AI operating system for edge AI data centers, specifically designed for managing fully distributed geographically and edge AI data center environments. We believe that we AI RAN Alliance, we believe that foundational groundwork for this new operating AI data centers can be prepared through the research and developments within the AI RAN Alliance. And strategically, this is critically important for strengthening the overall competitiveness of the AI data center ecosystem.
And Alex, I think I have time for one more question here. So I want to ask you to look a little further into the future and acknowledge that there will be a degree of speculation. But when you think about the push towards commercializing 6G somewhere in the 2030 timeframe, and then the R&D and commercial outlook for AI RAN, help me understand the overlaps. I guess one example that comes to my mind, and it's US centric, but 400 megahertz channel widths with 6G in the US, it doesn't happen without spectrum sharing. So that seems like it would require a highly distributed, intelligent platform just to deliver on that one aspect. But generally speaking, how are you thinking about AI-enabled RAN in the context of 6G?
Sure, yeah. As we move toward 6G, we are entering an era where spectrum sharing, massive bandwidth, and ultra-dense deployments make conventional manual network management completely impossible. So let me give you a concrete example, as you mentioned. It's a dynamic spectrum sharing. In 6G, we are currently discussing about this topic, multi-radio access technology spectrum sharing, in short, MRSS. MRSS refers to the dynamic sharing of spectrum resources across multiple radio access technology called the RAD, and such as 6G, 5G, Wi-Fi, and satellite, you name it, and also private networks operating in the same frequency band. So rather than allocating exclusive spectrum slices to each radio access technologies, MRSS enables a flexible real-time coordination to maximize the spectral efficiency, reducing interference and meeting a diverse service demands. So MRSS involves a real-time coordination across multiple wireless technologies using the same or overlapping frequency band. And this creates an extremely complex operating environment, and spectrum availability changes dynamically due to the interference, mobility, and environmental factors. Therefore, artificial intelligence technology is absolutely necessary because a traditional rule-based system simply cannot handle this kind of a complexity at scale or speed. So here is more specific on how AI technology can help in this space. AI ML models can predict spectrum occupancy and demand patterns based on historical and real-time data, enabling proactive spectrum allocations before congestion or interference happens. Secondly, reinforcement learning agent can continuously learn the optimal way to allocate the spectrums across different radio access technologies, adapting to changing network conditions and user behaviors. And in this distributed MRSS environments, AI agent at different network nodes, like a base station, edge server, even the satellite, can coordinate autonomously to balance traffic loads, reducing interference and optimizing end-to-end performance. So without artificial intelligence technology, the complexity and the speed required for the efficient MRSS operation in 6G would be practically unmanageable, and making AI native RAN architecture in 6G an essential foundation for the future.
There's a lot of work left to do, Alex, but I know that AI RAN Alliance and your entire membership is on top of things. So I really appreciate you taking some time to share your perspective with the audience here at the Telco AI Forum.
It's all my pleasure. Thank you.